Welcome to the eighth session of the Green Schoolyard Lecture Series. We're happy to have you here today. Okay, so on to today's lecture with Dr. Susan Day. She's going to share about how healthy trees, landscapes, and gardens are critical elements for schools, but that maintenance, of course, can be erratic. Budgets often stretch thin, and volunteers may not always be available. So understanding healthy soil can make all the difference. Many soils have been damaged by past buildings, as we know, construction, and may struggle to support healthy native plants. But through careful assessment and management, schools can turn this around, achieve healthy soils for healthy schools. So Dr. Day is going to walk us through some basic assessments and highlight rehabilitation processes for school grounds. So a little bit about her. Dr. Susan Day is a professor of urban forests and urban soil, specializing in the below ground portion of urban trees. She's pioneering research on soil rehabilitation and has informed best practices for land development, leading to healthier city environments and improved sustainability standards. Her research is focused primarily on disturbance from land development, soil blends, stormwater management, and constrained urban streetscapes. She has led numerous studies on soil volume, engineered and manufactured soils, soil compaction, so fill, rehabilitation. She helped shape the Sustainable Sites Initiative, sites, which, if you are a landscape architect in the room, you're familiar with that. It's a crediting system for soils and has published more than 150 articles and book chapters on urban forests and urban soils. She is Emerita Faculty in the Department of Forest Resources and Environmental Conservation at Virginia Tech, as well as holding faculty appointments at Oregon State and the University of British Columbia in Vancouver, where she was director of the Urban Forestry Program. And last but not least, she is a two-time recipient of the ISA's Elsie Chadwick Award for Arboriculture Research, and currently works as a consultant in Richmond, Virginia. She holds a BA from Yale University and an MS from Cornell and a PhD from Virginia Tech. So, without further ado, thank you so much, Susan, for being here today. For those of you who are in attendance, if you have questions and comments for Dr. Day, please drop them in the chat. We'll collect them for Q&A at the end. Yeah, so thank you again, Susan, for being here, and I'll pass it on to you.
Good afternoon, everyone. And I'm happy to be here to talk to you about soils. So what I'm hoping to do today is to just give you a sense of how to understand what's going on below ground in schoolyards and how you can work that to your advantage. So this is a picture of the British Columbia, UBC, University of British Columbia campus. And virtually every tree problem that you can see up here from this aerial view is caused by something below ground. It's either soils or root issues, right? So understanding what's going on down there it can really be make or break for your schoolyard. So today, I want to talk to you really about what are we losing when we go about business as usual? Business as usual in land development or building a school or building anything or even landscaping is usually just to forget about the soil, let it get destroyed, and go ahead and plant and sort of cross your fingers and hope for the best. I mean, that's really business as usual. But what do we lose by doing that, and what can we gain? So I'm going to sort of give you an overview of what kinds of things are going on in urban soils and what the consequences of those things are. And it has implications for all kinds of things: stormwater, irrigation, species choice, maintenance requirements, everything. And then we'll get a little bit more practical and look at how you figure out what's going on down there. How do you learn about your soil? How do you diagnose what your problems are? And so we have a very short time here today. So there's many, many more details we can go into. So I'm going to really be focusing on kind of how to get started, where to look for resources, and how to think about it. And that, if you're not familiar with soils, that can really sort of start you on your journey of becoming a soil plant expert of sorts in your area. And then, can you fix these problems? Some problems are very difficult to fix, but many can be addressed. And so I'm just going to give you an example, looking at soil profile rebuilding, which is a specification for rehabilitating compacted soil. It's specifically for soil compaction. So that's a physical problem when soils are compressed, but very, very common. Okay, so that's what we have for today. And then you can, in the Q&A, just feel free to ask about anything at all. It doesn't have to be about what we talked about here. Okay, so we're just going to dig in. So this is a tree. This is a picture of a tree being planted on the Cornell University campus in upstate New York. And I'm showing you this picture because we don't normally plant trees like this today. But this really gives you a sense of just how massive that below ground system is in a tree. It's enormous. Okay. So they have to get all of those roots that they're standing on there into the ground, right? And those roots are a whole world down below. And when we put in trees, typically in modern times, we're planting a tree that's, a couple inches, maybe 1.5, 2.5 inches in caliper. And it might be a container grown tree or a balled and burlap tree. And you just can't really appreciate what the root system is. It's been so reduced just for the transplanting process, right? So I think it's important to kind of understand what is going on below ground. So for a tree to grow, it needs to have a healthy environment, a healthy soil environment. Likewise, the trees actually contribute to the health of the soil environment. So this is a sandy soil. It's a Miaka soil in Florida. And it just shows very nicely. See where he's pointing that little dark area? That's where there's a root growing. Everywhere there's a dark speck is where there's a root growing. And the reason it's dark is because roots are constantly sloughing off organic material. They're growing and dying, right? They're pushing on the soil. They're making little tunnels. So the roots are contributing to the health of the soil. They're putting the carbon in there. The carbon isn't mainly coming from leaves falling and things like that. It's really coming mainly from roots. Okay. So the way the trees interact with your soil affects the long-term health of your soil and its function. So let's get back to urban soil. So most people are thinking of urban soils as just urban and degraded. This is me at a conference, and this is the room they put me in. Okay, so this is how we often look at urban soils. They're bad. There's nothing we can do about it, but there are a lot of problems, but we can do some things about it. Okay, so what are some features of urban soils? They're frequently moved around. Okay, so this is soil that was scraped from a building site. It's probably going to be sold and moved to some other building site. So there's all kinds of trying to get this. There's a little window blocking my view there. Okay. So they're moved around a lot, and just moving them means, one, you don't know what's there, but it also means that the moving process itself actually damages the soil quite a bit more than you might think. During land development, plants are removed, soils are scraped, and soil carbon is lost. Okay, so anytime you disturb soil, this is in British Columbia, they're clearing it for a building site, and all the carbon that was in that soil is going to be going into the atmosphere quite rapidly, okay, because it's been exposed to microbes by this churning up, okay, not to mention all the plants being removed. Then you have to remember also that soil isn't just a growing media, it's also a building material, right? So anytime we're building, you're already in direct conflict, if you're trying to grow plants, with someone who's trying to use the soil to hold up a building, right? So in this case, they're compacting the soil because they're actually going to put community garden planters on this. It's a little bit ironic, but this compaction is really part of any building site. Here's another one. This later became where all the trees were planted, right? Exactly in this soil. And they've scraped away the topsoil. They've compacted the subsoil in order to hold up the building and stage all this construction. And it's not going to come back on its own. All right. Now, there's also sort of chemical and contamination issues, which we probably won't talk too much about today, but we can talk about them in the Q&A if you're interested. And this is the Chicago, the north side of Chicago. And this map here, this sort of heat map, is showing the lead concentration levels in the soil. So there are lots of heavy metal contamination in some sites, but this is very, very tied to land use history. And we'll talk a little bit about that later, but kind of understanding what's happened on the land where you are is really important. And also, when we talked about transporting soil, in some cases, you have to be quite careful about soil that's transported and figure out, where it came from. I think as a whole, we're getting better at controlling that. And so this is the heat map, right? And then here is at somebody's house. This is in Lincoln Park. It's a multi-million dollar house and beautiful garden. And the lead levels are very, very, very high in this soil here right by this house. So when you look at what's there now, that's not going to clue you in. You have to understand what's happened there in the past. There can also be sort of more benign types of contamination. So this is where they're building a car wash, and all that gravel is a kind of chemical contaminant. It has a lot of calcium in it. It's limestone, and it's going to change the chemistry of the soil and raise the soil pH permanently, essentially, in this scenario. Okay, so all this area out here, which gravel's all spread and everything, that later becomes grass and trees. That's the planting area. Okay, planting areas generally create lots of nice open space for people to park construction equipment on, unless you protect it. And that leads to these kinds of micronutrient deficiencies. So this is a pin oak, and the leaf on the right is, you can see that it's very pale between the veins, and that's caused by that limestone, that high pH. Now, this is very regional. It depends on where you are. Some places the soils are so strongly acid, or the kinds of stone you have in gravel tend to be granite rather than limestone. So it's not universal, but this can be a really significant problem. Okay, so talking a little bit about the larger implications of soils, and this also relates to how you learn about soils, is that there's this fundamental relationship, which is genotype times environment equals phenotype. And basically that means you have the genes of your plant, it interacts with wherever you put the plant, the environment, and then you're going to get the way that those genes are expressed, like what it looks like. That's the phenotype. Is it big? Is it small? Is it, wide? Is it skinny? Is it healthy? All those things are part of the phenotype, right? And so everywhere you go, this is going on, right? So if you walk outside right now and look at what's growing there, and you look at what species it is, you can make judgments and kind of inferences about why it's like that. It's because of how it's interacting with the environment. And so if you go around, you see a tree that is struggling, just try to diagnose it. I mean, that's really how people can really build expertise in understanding soils and plants, right? And again, it's very, very regional. When I moved from Virginia to British Columbia, I had to relearn so many things, right? I had to start observing and carefully taking note of things to kind of build my expertise for that region. So just as an example, red maple is our genotype in this scenario. Our environment is this compacted soil with a little tiny cutout. And then this is what we get, this tree on the right. And I will have you know that I photographed this tree over a 20-year period and it did not change. It looked exactly the same. It's almost like it's not alive, you know. And so red maple in this is in Virginia is very it's one of the most commonly planted trees here, and it's commonly planted because it's very easy to grow in any kind of environment. If it were a magnolia, it would just be dead, right? That would be what you'd get after the equal sign, dead tree. So very few trees could grow at all here, but even something like a red maple, it has this stunted shape, very low rate of growth. And that's because of this interaction, right? So if you don't understand what this part of the equation is, the soil part, you don't have any idea what you're going to get at the end of the equation. And you'll see glorious drawings and schematics about how fabulous the landscape is going to look. It won't look like that if you don't have the soil to support it. So if you pay attention to your soil, and a lot of times in schoolyards, you can sometimes have sort of a blank slate, where not much has been done. You have just an empty field, so to speak. And you have a lot of opportunities to not only understand the soil, but also improve the soil, remediate the soil. And that can make a huge difference in how that equation plays out. And it can give you bigger trees, faster growing trees, healthier trees, less irrigation, more stormwater management, more shade, like everything. Okay. So how do you understand what you're dealing with in your site? Is your soil good? Is your soil bad? Like, how do you know? And so I'm going to go through briefly these three sort of scales. And I think if you're really trying to understand the soils in your area, you need to sort of start big at the mapping scale, I call it, go down to the parcel or the site scale, and then get down into the tree level or the garden level. That's where you're taking soil tests and looking at things like that. Okay. And together, this will give you a good picture of what's going on and help you understand your site and many sites in your city, right? So it's where you can sort of build your expertise. So think of it, this is my former dog. Unfortunately, he died last year. But think of it as sort of a detective game. Okay. You're just trying to figure out what's going on down there. You can't see it, it's underground. So how do you figure it out? Okay. So the mapping level. If you're not familiar with this is the Web Soil Survey, and it's a great place to start. Now, in a lot of urban areas, there's very little information. That's changing. Like Los Angeles, for example, has a lot of urban information. Some cities do, many don't. But even if they don't, you can learn what used to be there before there was a city. Okay, so think of this as very large scale. You're looking at things like, if I were to dig a hole 10 feet deep, what's down there? What kind of rock is down there? Or did this soil, when it was farmland before we built this subdivision, did it drain well or was it flooded? These kinds of questions. What are the sort of, is it strongly acid or basic? Does it tend to have a lot of clays in it or sands? I mean, there's a lot of things you can learn from this survey. And so you just drill in, you find your area of interest and you drill in on this map, and you will get details that are super informative. You can learn about the soil series that are where you live. Okay. Now there's other things to do that are more specific to land use in your area. So you might find out things like what I'm going to show you here just by asking people, looking at Google Earth. Okay. So here we have some trees, right? This is farmland. Fast forward, this is what's here now. Those trees are still here, right? So if you're looking at the soil here or these trees, it helps to understand that this process occurred. And you can just imagine what was involved in that and how that might have affected the soil. And that will help you figure out how to test things. And this idea of soil being moved and grading and terracing is, if you have any sort of topography, so this is outside of Los Angeles, or maybe part of Los Angeles, there is a lot of grading going on if there are any buildings. And so these pictures, the one on the left is just lower resolution. The one on the right is higher resolution data, which we increasingly have available to us. And it looks like little gears or like a computer board or something. But what that is the grading for housing. Okay. So every single house has these carefully engineered cuts in the grading. And that means soil's taken away and soil's brought in. It's moved, right? And if you think to the layer cake that we started off with, soil is naturally in horizons, right? And it's formed over many tens of thousands of years. And it has this sort of natural layers. And as soon as you start doing that, you're shuffling all the layers around. So when you're trying to figure out what's going on, just think about what those horizons are. You can learn what they maybe should have been in the past from the survey. You can think about how soil was moved. And you also, like in this case, they laid sod in this landscape. And that's why there's this thick, dark area here at the top. And then this soil down below is a compacted B horizon, right? So you're just trying to understand like what happened. The other thing you can do, and this is what they do when they create those soil surveys in cities, is just take advantage of any excavation. Someone is replacing utilities, like get over there with a camera and start looking, right? What went on? So here, they're doing something with this utility line. I can see that the tree roots are confined to the surface. I can see this like dark kind of layer down there where there used to be fly ash for parking. I mean, I can go back in history, reconstruct what's going on in here and understand what's below ground. Here's another layer situation. This is where there was fill soil brought in to raise the grade, and the roots of the existing trees are now they're much lower in the ground. They're down there, but they're underneath this cap of soil. You can just look at the terrain. So here's a cut. You can see where the parking lot's going. In the back of the picture, you can see the original slope of the land. That's where those surface horizons are, right? So if you're down here, don't expect to find any of those. They've been removed, right? So you can just sort of figure it out. You're reading the land. So looking at this picture, what happened here, using these techniques, I can tell you that there's this new building here. There's a slope over to the left. We're on top of some fill. I can tell it's compacted because of the way the soil's ponding. This is my husband. He stuck a stick in the ground. It only went down a few inches. That's how far it is to the compacted subsoil. You can see that there's no structure in the soil because it's been moved and churned up and spread around. So you can learn a lot just from like these kind of big picture things. So this site probably looked like this before they did any planting. Okay, so this is, in this case, they went ahead and planted the trees before they even replaced the so-called topsoil. And this area here is all heavily, heavily compacted. Okay, so as you get down to the garden scale, you can just start poking around. Just get a soil probe or a trowel or whatever you have, and just start sticking it in the ground and looking around you and trying to figure out, what's happened here. You can do a simple drainage test, dig a hole, put water in it, see how fast it goes down. You can use something called a penetrometer, which is this tool on the right with this sort of sharp point, and you push it into the ground and you're trying to detect things like here on the left, like that tool would hit this sort of asphalt layer and this gravel, it would stop, right? Or if it hit a compacted layer, it would get harder to push. You can figure out what those layers are. This can be a very expensive piece of equipment, but there's cheaper ones, and you can even just use like a metal rod. So here's someone testing the layers in this tree pit here with a penetrometer. Okay. You can also just look at what's growing. So for example, this is that same soil I showed you earlier. And what's interesting is these two pictures are taken 6 feet apart. And the difference is in the picture on the right, they were growing vegetables. In the picture on the left, they weren't doing anything. So in the vegetable growing side, they were adding lots of compost all the time. They were irrigating it. There were all kinds of herbaceous plants in there that you might eat, which are sticking carbon in the ground. And so it built up carbon over time. And that's essentially the difference. So you can see two things, like how the plants might be contributing to the soil, but you can also kind of diagnose the soil based on the plant. So, for example, if I see that red maple looking all shriveled and not growing, I know there's something going on below ground, right? I can tell because the plant's like an indicator. All right, so let's talk about what you might do about this situation. So I'm going to focus on just one example, which is soil compaction. And this is an extremely common condition anywhere where there's been building. And so that includes virtually all schoolyards. Some schoolyards are all fill or all cut as well, because there's often an effort to make like playing fields and things that are level for children to play on or put playground equipment on. So you might have a lot of soil movement. Soil compaction tends to be worse when you have more clays in the soil. It's a little more compactable. If you have extremely sandy soils or, say, volcanic soils, you might not have as many problems with this. Okay, so in this case, the soil that's right beneath this sort of topsoil that you see here that's rutted is extremely compacted, B and C horizon soil. So those are like the lower levels. And in this case, it's probably a clay loam, which means it has a fair amount of clay. Not it would be an excellent soil for agriculture if it hadn't been damaged. Okay, so what happens when we compact soil? So this is a picture showing soil aggregates. And so it's important to kind of understand what this concept is. So these little kind of crumbly things here that the roots are growing in between are aggregates. And essentially what they are is they're just clumps of soil particles. So clays are microscopic in size, and sand is larger, and silt's kind of in between. Those are the mineral particles in soil. And they form these little crumbs that look like cake crumbs, and those are soil aggregates. And that's essentially the magic of soil. Okay, and I'll explain what I mean in just a minute. So the analogy I like to use are these balls of yarn. Okay, so imagine that each ball of yarn is a soil aggregate. And so it's made up of all the wool fibers that are kind of held together in this complex structure, right? And then you can see there's spaces in between the balls of yarn. So in a healthy soil that's not compacted, air and water can just like easily move in between these balls of yarn, right? Just flows right through those big gaps. And then the balls of yarn, or the aggregates, they hold all this stuff. They hold carbon, they hold nutrients, they hold water. So you can have like good drainage, yet still have water for your tree to take up, right? So it's this kind of magic system that's both porous and has these little aggregates that contain all this wonderful stuff. Okay, so what happens when it's compacted? It's not pretty. Okay, there you go. We made it into felt. I mean, I'm using the wool analogy. Okay, so felt is essentially like compacted balls of yarn, right? So all those balls are gone and everything is just kind of flattened and homogenized. So it's the same thing with soil. If you imagine those aggregates just getting squished into, like soil, if you squish it in your hands, it looks like you could make a pot with it or something. Water won't flow through it anymore. Air can't get through it, and it can get really hard too, like a brick. And then roots can't push through it either. Okay. And so that creates this system. So in that picture I was showing you, which is this one, okay, essentially what is going on in that picture is this. You have this compacted zone of soil. And in that case, because of my understanding of the land use history and the fill, that compacted zone is probably much deeper than this. But if it were a flat area that hadn't been graded, it would look like this. And then all the roots of those trees, when they grow, are going to be confined or largely confined to the surface. And so that means two things. It means, one, you're not getting the roots in the compacted zone, so you don't get the roots changing the soil for you. It's just going to stay like that for a really long time. It also means if it gets it all dry, those trees are really exposed to drought. It means they're not going to grow as fast. It means if any storm water, when it rains, it's going to pond, just like you saw in the picture. Okay, so that's not good. So, how do we fix that? The technique, this is one that we developed in my research lab, and it's quite simple. It's meant to be simple. It was sort of inspired by some mine reclamation work that they were doing at Virginia Tech. And it's called soil profile rebuilding. And you can Google it and get the specs. It addresses this specific type of soil compaction, the subsoil compaction. It increases hydraulic conductivity, which is KSAT, soil carbon, and accelerates tree growth. Okay. So, what is it? This is the website. So, if you Google it, you can find this website, and it has all the stuff that you might want. But basically, this is the process. Okay. So, here's your compacted soil on the left. The first step is you spread some compost. The second step is you use a backhoe and you lift and you let it fall and you kind of get these veins of compost down in the soil. This is where you're breaking up that compacted zone. Step 3, you put the topsoil back, or that was taken away originally. Then you sort of finish it by rototilling the surface. Then you plant your tree, and then the roots can get in there, the water can get in there, and everything is good. So here it is in practice. There's some compost. Here's the backhoe. They're working backwards, so you can see they're on top of the compost, but as they back up, it's getting incorporated, just big lumps. And then you get these roots, you plant something, and the roots start to improve the soil. Okay, so when you compacted the soil, you destroy those aggregates. So your task is get the aggregates back. That takes time, takes 5 to 25 years, depending on conditions. It's not better to protect the soil if you can, but you need the roots in there to kind of get the process going. And here's just some examples of some results. So, like in Arlington County, Virginia, they use this technique as part of their stormwater program. So, it's required around buildings to restore the soil or rehabilitate it within the limits of disturbance. And so we did an experiment there in medians, essentially. This isn't the median part of it, and so this tree on the left is a scarlet oak, where this little tiny area there got this treatment. So you treat the entire area. It's not a planting treatment, it's for all the soil. This one on the right didn't get the treatment. So one, you can see it's a lot bigger, but I also want you to think about another feature of tree planting, which is the structure of young trees. So see how this one on the left has a nice, strong central leader? This one on the right does not. Why is that? That's because of transplant shock, because the soil was bad. We planted the tree, it got dry, the leader died back, and then you got 3 or 4 leaders coming out, right? So you might not think that addressing soil issues is going to save you on pruning costs, but it is. Here's just a graph showing the green bars are treated and the gray are not in part of this experiment. And it's essentially, this is just the size of the tree after, I think this is after 2 years or something. They just grew a lot faster, and they also, many more survived. So the benefits of addressing this kind of problem proactively, so soil compaction, is you're going to have success in the whole process in a way that it's hard to have if you don't address it, right? Because you're just going to be fighting the soil, and it's very hard to fix it after the fact. So if you remediate the soil beforehand, you'll get faster establishment of the trees, less irrigation, bigger trees, more species choices, right? So if you think about poor soil, people are like, oh, well, what will grow here? Maybe an elm tree, maybe certain trees can survive really poor soils, and those are the most common trees. You want to plant the right tree. You might want to plant certain kinds of native species or whatever. You want more diversity, so it's going to improve your choices, more drought resilience, better soil health. And there is a whole ecosystem in the soil, which we haven't talked about, but if you don't address these issues, you won't have it more carbon, better stormwater management, everything. Okay. So that was just kind of my overview here. So I just want to acknowledge many of my students who has helped me with all kinds of these projects, and also funding agencies like NSERC, which is in Canada, and the Tree Fund. And I think I'll stop sharing if that's okay.
Thank you so much, Susan. That was very informative. A lot of good, rich information. Um, we've got lots of good questions. And yeah, I see people are still adding some more questions, so we'll just go through the list. Are there any special considerations for areas that have been recently depaved? So thinking about, the removal of asphalts and rehabilitating these areas for planting or planting trees.
Um, yes, so that's a great question, and actually that's a very common scenario. Like in that study in Arlington, most of the sites were where they were creating planting areas in the middle of streets. So they're talking about things that had been under pavement for 40 years. And when they were first approaching this problem, they knew the soil was going to be bad. It's had no organic inputs, it's heavily compacted, it's got a lot of stuff mixed in it. Um, and so they were considering just excavating and trying to replace it with something. This can be really challenge. This is very expensive and also can be very challenging because it can be very difficult to find an appropriate material to replace it with. Like you can't just go out and buy real good soil. It isn't, that's not the way it works. So they decided to try the soil profile rebuilding on that, and it was very successful for them. It was a way to kind of rebuild the soil in place and use the existing soil, but they did have to bring in some topsoil. Now, as far as like if people are concerned about contaminants from the asphalt, there were sub like base layers of gravel, which did increase the pH in those sites to some extent. But as far as like contaminants from the asphalt, even though it has petroleum products and so forth in it, it didn't really, it wasn't a concern for affecting tree growth, and those things do break down over time.
I know that is a consideration for a lot of schools,
Mm-hmm.
especially ones that are getting funding for removing asphalt and
Yeah.
considering what's
Well,
happening.
I would
Mhm.
say like the compost has incredible power. Like we haven't, there's not time to talk about this, but if you're purchasing compost to do any kind of soil remediation, it's a good idea to kind of learn about compost and compost quality and what you have available and so forth. You might have to work with people to get that, but it doesn't take a lot of compost to have a really positive effect. And so you'll see like that the technique that I showed you in this example, it's really not a lot of compost, but it has a very powerful impact on the soil.
So that sort of leads into, and honestly, we probably could do another session just on compost.
Yes.
Um, but someone else has a question about remediation of soil around an existing tree or around, I imagine, a mature tree. And so I don't know how compost would factor into that, or if you had, for example, that the example you gave of that small red oak in the tree well, like how can you
Mm-hmm.
help that tree without harming it if it can't be moved?
Yeah. So the soil profile rebuilding is only where there's no trees, right? I mean, it doesn't work if there's a tree because you're disrupting all of the roots. So if you had that little oak that I showed you and you wanted to remediate the soil, you'd have to just remove it. You could pull it out with a tree spade, remediate the soil, and put it back. It'd be possible, but like it might not be practical. And then for a larger tree, if you have larger mature trees and you think that there's soil compaction issues, like someone has, say, parked over the tree roots or something like that and compacted the soil, you're kind of limited in what you can do. There's a few things you can do, but you do have to be a little careful, and they only do so much. And so if your tree is in decline, it's unlikely to turn the tree around. Like sort of the dynamics of large trees is a whole nother part of this equation, right? Their carbon balance and so forth makes it difficult to turn the situation around if it's to the point where you can actually observe decline in the tree. But that being said, there's a couple of things you could do. You can add organic material like organic mulch or compost to the surface, and those organic compounds will leach down into the soil, and you will get some extra organic inputs into the surface soil, say the top 6 to 8 inches, that can build soil aggregates and address compaction. Another thing that people do is they will use like an air spade or an air knife. It's like a air compressor attached to sort of a metal stick that blows air, and you can work around roots with that and sort of
Hmm.
churn up the soil a little bit. But when you do that, you can damage fine roots. I mean, it's not like it doesn't harm them at all.
Mm.
And you can only go down so far. And when you're churning up the soil, that also can destroy soil if it's good. Now, if you have really compacted soil, it could help. It could definitely help, and you can incorporate compost and things like that in there. But there's sort of a limit to how much you can do with that. And as I said, if you have a mature tree and it's in decline, it's very hard to turn it around,
Mm.
if not
Hmm.
impossible. Proactive, protect the soil. Yeah.
Someone is asking about tools and rototillers. John is asking about are there any negative consequences of using a rototiller? Have rehabilitation efforts used mechanical spades like an organic farm tilling in place of rototillers to incorporate organic material and reclaimed soil?
So any tilling, it doesn't matter if it's on like you're disking the soil or you're using a rototiller in your backyard, it breaks soil aggregates and you lose soil carbon. So there's sort of a benefit to what you're doing, but then there's a loss. And so you have to kind of, that's why it's really important to understand what you have. Like if your soil is in good shape, you don't want to be just running around tilling it. You can
Hmm.
mitigate that by tilling it when the moisture levels are right, not extremely dry and not extremely wet, sort of in between, and not overdoing it. But that being said, like in the soil profile rebuilding, that's why what you're doing initially in that is you're breaking up that compacted layer in really big chunks. You're not tilling the compacted layer very much, at all. You're just kind of incorporating pieces of compost down there. And essentially, you're just breaking it up so that the roots can get in. And then once the roots are in there, they sort of follow the path of the gaps made by the compost. Then over time, over 10 years or whatever, they will be rebuilding that soil, right? So on the
Hmm.
surface, your tilling is going to be depending what you're planting. I mean, if you're planting vegetables or something, I mean, these things are different than trees. um, but you don't want to overdo it, and it's you're not going to be able to incorporate that much compost by tilling because it's just impossible to do. I mean, if you tried to put 4 inches of compost and till it in, you'll find it quite difficult to do. So because a tiller only goes like 6 to 8 inches deep. So I don't know if
Mm-hmm.
that answers the question, but it's not. It is destructive. It's not, but if it's going to break up soil compaction and get more compost in there, then it will probably be worth it because it's not as destructive as some other activities.
Hmm. Someone else is asking about like ways of of preparing the soil before planting certain trees. For example, um, like thinking long term, like 40 years, by planting first some kind of like pioneer species, some kind of like pioneer fast growing tree, and then later replace it um, with the tree that they actually want long term. Would that help prepare the soil? Does that make sense?
It's going to have probably limited effect on the soil. I mean, so for example, like even something that will do like that red maple I showed the picture where they were digging around the utilities. I mean, the soil was very compacted there, and you'll notice that even the red maple, which can tolerate quite a bit of soil compaction, and there's a physiological reason that some species can tolerate more soil compaction, which we didn't go into here, but um, most of the roots were not growing there. The roots grow in the path of least resistance, right? So if you're hoping they're going to go down and look for the worst possible soil to grow in to break it up for your future planting schemes, it's kind of unlikely. Now, I mean, like in agriculture, there are certain root crops and even cotton, like people have used to sort of penetrate compacted layers and break up the soil, and they can have some effect, but it's probably a lot more practical just to do it mechanically. If you know where the soil is compacted, it's more practical to just get a backhoe and break it up.
Mm,
And a good
mhm.
backhoe operator, like if you do that testing and you like put a penetrometer in, or the history, or you've watched whatever, and the depth of compaction, you can have a sense of what's required, right? And a good backhoe operator, when they put those tongs in, they can feel when they get through the compacted zone. Suddenly
Mhm.
it gives a little bit, right? So they'll be able to actually make judgments as they're working through your compacted zone.
Okay, yeah, that makes sense. There are so many questions and we only have a few minutes. So,
Okay.
sorry, folks. I'm just gonna select a couple, and the ones that aren't answered, maybe we can send to you after the fact. Um, Melody is asking about like new school development, and I know someone else in the comments was saying, like a lot of schools where I live are over 100 years old, so maybe this is applicable to both. So, how might this be practically scaled for new schoolyard development? It seems like the entire site gets leveled and then the outdoor space is done last, but I've not seen developers do soil remediation before planting. Is this something that we should be requiring? And if so, is it cost prohibitive or why is it not happening?
Okay. So there's many questions wrapped up in there. And I will say that yes, they should be doing that. And it is not cost prohibitive, first of all. And I would also say that in new sites, like if someone's building something right now, a soil protection plan ought to be part of the plans, right? And that would be something definitely worth pushing for. Um, so, for example, I mentioned Arlington County, they require that you protect and fence off, these areas where you say you're not going to disturb, right? So beyond
Mm,
wherever you say, I don't know, you're building and you need 40 feet of space to work around the building, let's say, and then beyond that it's fenced, right? So it's protected, and then they must rehabilitate all the soil that wasn't protected. Okay, so it's it's possible to do, and you might think that's, it sounds crazy expensive to do acres and acres and acres of land, but you can actually do that. And in another alternative you could do it, but truthfully it's not as effective, is you could use an agricultural ripper, This is what they do in like mine land reclamation. If you have if let's say you have 20 acres of soil you're trying to rehabilitate, um, you can rip it, and that's sort of like a subsoiler, and you could go multiple directions. But I will tell you that when you do that, you're not treating all the soil, and you can see it.
Mm.
It's not as good. So yes, you can do it, and the reason it's not done isn't so much because it's really expensive. It's because it's very hard to convince people that it's worth doing, because most people aren't aware of what's underground. Like they don't see it, and they don't really fully appreciate the impact it has on trees. So you plant trees, and if they die, the contractor will replace them, and eventually something will live. And so it's it's hard to sort of get the message across, I would say. I did talk with someone from Arlington County just last week. Saw them at a conference, and they said since they've been doing that, they can just physically feel how much greener it is, because the trees are just growing faster and bigger, and they're healthier. So it's it is worth it to do. But they're right. It's like business as usual is just the easiest thing to do, is just level everything, and then build, and then just sprinkle topsoil on top. And that's the easiest thing to do. But it's really just a planning thing. It's not that hard not to do that. It's just that you have to talk to people and convince them and get it in plans and get specs and standards and such. And then
Yeah,
the
that
question
sounds
about
like,
the old schools, I also want to point out, like,
mhm.
development that occurred before, say, 1960, 1970, was done with different kinds of equipment, and it was just much harder to do this massive grading at that time, right? So soil tends to be much better condition if it was originally developed 100 years ago.
Hmm, that's very interesting. And we also think about schools built 100 years ago that have big windows that were built after the Spanish flu, for example, and
Mm-hmm.
airflow. And, are we can we return to some of those things that were actually done well 100 years ago? Um, we are at time, but I want to thank you, Susan, for all of that amazing information. Any last bets, Susan, and then we'll bid everyone goodbye.
No, just thanks for having me. And I do want my last sort of just statement to everyone is just think about the soil. Like when you walk outside today, look at a tree, and then look at the soil and try to think, what is that interaction that's going on? How is that affecting this tree, for good or for ill? And if you start doing that with every plant, you will learn so much.
Thank you so much.
Okay.
And have a wonderful day, everyone. Hope to see you again soon. Thank you, Susan.
Goodbye.